So we're going to talk about our second type of curved mirror today.
Oh, looks like we got a math problem. So, it's like, you don't really need to do math.
Really? I don't know.
Okay. No, thank you.
Alright, so we talked about concave mirror. Now we're going to talk about convex. Oops. So concave, light comes towards the cave. Convex, opposite. Yeah?
Yeah.
So they give you the physics definition. It's the mirror whose reflecting surface is an outward curved bulge, essentially. Okay? Examples of this.
Car mirrors.
Car mirrors are convex. Now you would probably be able to look at a car mirror
Spoon.
and sort of see it.
Other side.
Other side of a spoon. Have you ever seen one of those Christmas tree ornaments?
Yes.
That's going to be a convex.
The ball at Chicago.
Ball
The
at
bean.
The bean at Chicago.
Nice.
Depending on where.
Yeah, you know what's trying to be? It's like Big Shotty.
It's like this massive random blob of mirror.
It's a ball of mirror. It is huge.
Cool.
Or not cute. It was.
No, it is huge.
Oh, okay. Yeah, cool. We're gonna,
Do you know what the bean
maybe
is?
we'll take since everybody else is
You know what
school field
soybeans
trips,
are?
maybe we'll just all travel to Chicago and see some real beans.
Yeah. It's just a mirror bean. It's a mirror thing.
Is it a bean or a mirror?
Whose
idea was that?
It's a shiny shape.
It's a
I
shiny.
think I maybe have.
Look it up. I'm probably seeing it.
I hadn't heard of it
Yeah, right.
until.
Okay, light rays diverge. Okay, does anybody know what diverge means?
Diverge. They come together.
That's converge.
That's the
Like,
opposite.
They
opposite. So
diverge.
the opposite. Yep. So converge means they come together. Diverge means they go away. So if a convex mirror diverges the light, will those light rays ever meet at one point?
No.
No. So what kind of image will this always
Virtual.
produce?
I
would
know. I always
accept
say the
that.
wrong word though.
Okay? Every single time you're going to get a virtual image, which means it will always be on the opposite side of your mirror. Okay? You will never get a real image. And it will always be smaller. It will always be smaller than the object. That's why those mirrors in your car say objects appear to be
Further away.
Closer than
Closer than.
Oh,
the-
closer. Objects in the mirror appear closer.
Maybe no, it's
Or
maybe
are closer than they appear.
Yeah, are closer than the
So
other.
That should make any
Maybe
sense.
I
closer
always thought it was
Whatever,
the other way.
maybe.
Like I would be, that's what I thought.
I mean, because if it's in your blind spot, it's definitely not close.
That they were like closer in the mirror.
So, this is probably, I don't want this to overly confuse you.
No, they are close. They're
Okay.
closer to your car than the mirror.
I'm going to try to at least kind of sort of show you all the rays here. So all of these rays are coming from this point right here. Okay, so here's the first ray. Goes like this, and it gets reflected away. Okay? Right here, I'm going to use a different color. Goes like this, gets reflected straight back. Like that. This last one, reflected from the same point. Now you guys understand that these aren't the only three rays that are going to come from that point. Light's going to be scattered from that point in all directions, but it would look really crazy if you had 1,000 lines on this page.
No.
Okay? Now, what happens here is all of these light diverge away from each other, so they are never ever going to converge at one point, so they're never going to form a real image. Okay? Well, your eyes are going to see the light, correct? And if your eyes see the light, it had to come from an object. Yes? So what your eyes do is your brain actually diverges it back, or converges it back. So watch. Okay? The light from here, your brain says, came from there.
Yeah.
The light from here, it converges to there. And the light from here converges there. And so what your brain does is converge it at a point behind the mirror equal to the amount of time that it would take to get to your eyes. So your brain believes that light actually just came from here and went straight to the eye. Okay?
Mirrors?
What?
Are mirrors even real?
What if, why
Or
does
is it all our
camera?
brain?
What?
It is.
Why
They're
is it
fake.
what?
Why does the white
Our
doesn't
brain
look
is
at the
making
camera? Let me take a
It's
picture
not
of
a
it.
mirror, it's
Christmas
our
when you'll
brain
see the
making it
camera.
up. He's literally just saying your brain.
What makes a
No, the mirror is actually there.
No, it's
Why
what
does that bother
is
you?
the
Because if you record it on
That's what
camera,
makes
it's
it
still
say if
there.
your eye does it, why does the
The
camera?
effects, the effects of a mirror is what.
Yeah, but like,
No, but it's like recorded with the camera, it's still there though.
So-
It's not just your brain.
You're saying when you take a picture of an ornament,
You can see the camera. I guarantee you.
Ew,
can see the
stop.
camera. I've seen those pictures.
That's what
That's why you can't see vampires in theater.
that makes sense. How come you can see a reflection in like a car window and it's not a mirror?
It's not-
It's
it's
just
not-
still
it's
a
not-
mirror is any reflecting surface.
The glasses are included.
What?
A mirror is any reflecting
It
surface.
seems like you're both. We're not talking about a mirror, like a bathroom, like.
Yeah.
Well, that's a type of mirror, but that's a mirror.
A spoon is not a mirror.
Mirror
Yes,
is-
that's
Or
a
a
spoon
mirror
is a
is-
mirror, but it's not like.
It's a reflecting surface. It's the same idea. That's just a
Hey,
type
black
of
mirror,
mirror.
Autumn.
Did you know that?
Mirror.
I didn't know that.
Yeah.
I thought we've been talking. I've been trying to figure out how we have a curved mirror. Like, who looks in a curved mirror every morning to get ready?
No, yeah. No.
Makeup ones?
Those are, the mirrors in the bathroom are one type of flat mirror.
Yeah, there are.
But you can look at your phone, that would technically be another type of flat mirror. You can look at any reflecting surface.
Oh,
She
magnifying.
literally like, who looks at concave mirrors? And she literally does.
Wait, is it like to magnify your face?
What?
Like the mirrors that like
Magnify.
Make it so your face
when you
is way
get
bigger.
close,
Oh, I don't
it
wanna do
magnifies
that.
and you can see your zits real fast. And I'm always like, okay, Pete.
Sure.
Wait,
Yeah.
that's the concave
Is
one.
that a concave mirror?
And
Yeah.
then convex.
They
would
both
make it
no, they
small.
both go in on mine.
No, because.
And one of mine is normal.
It
And the
doesn't
other one is
distort. It would be
magnified.
I would-
convex. 'cause
I
we
don't
talked about this
know.
when
Yeah,
I wanna
it's-
say,
It's the
Shine's
concave
bringing it
because
into
when you get too
convex.
far away from it, then the image will flip.
that would make sense.
Yeah.
No, that's like a spoon.
So
No, yes,
basically
it
you gotta
does
put your
flip.
face inside the focal point.
Yes,
Yeah.
you have to get close to it for it
That
to
makes
work,
sense.
and then you
Yeah.
can't put on eyeliner very well because it's too close to your face. I've mastered the
No
art of the
problems, I guess.
concave.
Alright?
See,
That's
I
so
know,
funny.
I know
Wait,
a little bit about
why-
makeup.
Why is
I have
the
no
image
makeup every day.
not as far as the
Oh!
actual,
What is
actual object? Like the actual object is like this far from the mirror, and then the image is like this far on the inside.
Because of how your brain diverges the light. Or you're talking about like that, this is further away than that.
Works so bad.
Dude, you mean by we, you mean me and my mom?
That was aesthetic.
What do you say?
That one was acidic.
We're gonna do one of these.
Did it burn a hole in the chair?
No, but I do have a.
Oh.
Go ahead, please, sir.
Well, all these are recorded.
I don't
We're like,
know.
No, I
know.
have some unused.
He's like,
There's no compilation of all I said.
I have unused that I like to.
Yeah, sure, I understand. It could be that this is just a
Wait,
full
what did you
piece.
say?
I'm not.
What?
I wouldn't
Because
think.
I have unused that deteriorating. You actually.
What?
Oh,
He farted so much, his farts are
He
acidic.
farted with me like 5 inches from his behind in the hallway. I'm like walking behind all
No warning.
just like, and I'm just like, it like hit me. Like stop me in my tracks.
Wave of
It
staying.
was a wave, it was a sound wave and a light wave and a,
It was a sweat shit on
You
the
can see it with your eyes. There's a light.
It was a juicy wave.
Ew, juicy.
Gross.
Here we go. Parabolic mirrors. Okay, now, we've been doing just like perfect spherical mirrors, which means they are like half of a complete sphere. Okay, you guys know what a parabola is, right?
Oh, yes.
Arabella.
So, what can actually happen, and I want you to open up your books because it gives you, it gives you a better picture than I can draw.
It's a picture on our paper already.
Oh, nice. Let me just go to the next slide, probably. All right. So here's what happens. If you have objects that are relatively far from the mirror, you can get what's called spherical aberration. What that is that the light rays that hit the outside of the mirror actually converge at a different point than the other rays on the inner part of the mirror, just due to the fact of the curvature of spherical mirrors. What that does is creates it's called aberration, but basically what it does is it makes the image blurry. Okay, we're getting into what happens when you need corrective lenses for your eyes. Okay? Now, what they do is they give you what's called a parabolic. If you have a parabolic mirror, it corrects for this and allows the light to converge perfectly or better. All right?
How does it go wrong?
It has to do with the curvature of the mirror. I don't know exactly.
So like your eye becomes weird and curved, and so then they give you something to make it curved, right?
Yeah, essentially, the lens in your eye, I don't know, over time must change.
Wait, so the contact
It's 'cause-
corrects it?
Yep, the contact like squishes your lens in a way that makes it so that light will actually reflect on your retina or cones or
It's
rods.
because
or
your
whatever.
lens.
Same idea. So it actually, so it doesn't squish your eye lens. It actually just it dive or converges the light onto the back of your retina. So
It
like
converges the light for your eyeballs, and your eyeballs can't do it.
yeah, or it helps your eyeballs. The lens in your eyes.
eyes.
Yep. And so I think
Your
there's
lens is tough over time.
You can't do your AT anyways.
Because you have the muscles in your eyes.
maybe that's a different lesson. Oh yeah, that's a different lesson when we talk about lenses next chapter. But yeah, what essentially happens is a lens will make it so that the light that goes through your eye actually hits the back of your eyeball. I think it's with cones in the rods.
Yeah.
Retina. I don't remember. I don't know all the. It's been a while since I've done
It's like
anatomy. You guys probably know it probably better than I do. But when it doesn't focus, when the light doesn't converge on the back of your eye, if it like converges behind it or in front of it, that's why it appears blurry.
Oh, my lantern.
What makes it not converge at the focal point though? Like this spherical mirror is not converged at the focal point.
It's the result of how light rays are going to reflect off a spherical mirror. It's just due to the curvature of the mirror. So what ends up happening then, and we'll get into lenses, and I don't want to over talk too much about that because I do want to get to the math problems. But so we're gonna spend more time talking about lenses next chapter. So I'm just gonna leave that for them, and let's get to this problem here.
I think this is more fun than what we did last semester.
I like this stuff. I think light. This semester has some of my favorite parts of physics and my least favorite parts of physics. I don't like sound. I just don't.
Yeah, that's not
It was easier than this though.
Yeah, but to be easy and interesting.
See, I don't think it's easy, but it's more interesting.
I also think, and this is my personal opinion, I also really like electricity. I like circuits. I like magnetism.
When do we do that?
After this.
Are we gonna do the thing where we connect the wires to batteries and
Yep.
light?
I have a circuit board that will do. Fortunately, I have.
Well, I haven't noticed you
We did that in 4th grade.
block Wi-Fi.
Did.
No.
Okay, here we go.
It's not required to graduate. Is it too late to graduate?
Something that you need to know.
Where is it?
It'll take you 2 days.
To this, but I didn't want to be like everyone over there.
Okay, you're gonna need to write this down somewhere. Focal point for a convex lens is always negative.
So you can never get to the focal
convex mirror or convex lens?
Oh shoot, I wrote lines, but you mean mirror, don't you?
Did I say lens?
Yes. Shoot. Pen, Kramer.
Sorry.
I've learned to never write
Oh.
Accept your mistakes all the time.
well, especially like spelling stuff on the board. I learned to just.
It's okay.
Why do you need
I'm not saying it's a bad thing. I'm just saying.
Yeah, I'm not offended by that.
Okay, good. I kind of sounded rude after I said it.
It was a little.
Just correct.
I don't get easily offended.
You're a feeler.
Yeah, Craig, you're a feeler.
I'm a feeler for you.
He's sympathetic to emotions and people.
Everyone is to an extent.
To an extent, but there's people that are
He's a
more
tender
sympathetic.
man.
Are you
Craig's
more
the
sympathetic,
feeler.
Kramer?
Yes. Unless you drive me nuts.
Do I drive you nuts?
No, Lars drives.
Alright. So there we go. I want to show you here, like, because if focal point we said is when parallel rays come in, it would be where they converge at one point, correct? But a convex mirror, they never converge. So technically, you wouldn't have a focal point over here if they never converge. So the only place that they would converge is if you took the line back behind the mirror, and that's where they would converge. Okay, so light comes in and diverges, but if you bring the light back, light comes in, diverges, light comes in, diverges, but if you bring the light ray back, it actually will converge behind the mirror. And so the focal point for convex mirrors is going to be behind, which means it's always going to be negative. So you will have to always put a negative on your focal length for convex. I just call them diverging mirrors.
So the concave one makes it so it goes straight back out, and then the convex makes it like go into it.
Yep. So concave, positive focal point, convex, negative focal point. Okay. Upright pencil placed at a convex mirror, focal length. So it needs to be what? -8 centimeters. And erect image 2.50 centimeters tall. Image, is that H prime or H?
H. Not prime.
H prime.
Why?
Image is the prime, object is the not prime.
Hold on. Image is prime.
You should have that.
I know, but I'm gonna write it on this page.
Image is prime, object is without the prime. Okay? So an image is formed 4.44 centimeters behind the mirror. Ah, we got another behind. So what I gotta do?
Negative?
Yep.
Wait, so is that age?
Yeah, why is it not H?
No, this distance. No.
Oh.
So this is your image height. This is where your image is forming. So that would be Q.
Okay, cute.
What'd you
Wait,
say?
Q
Big boys.
Q is where it's being formed. Q
Q is image distance.
Like distance
No,
from the
it says image 2.5. Isn't that the image distance?
Tall.
Yeah, tall. The distance, tall.
Yeah, upward.
Yeah.
Okay. Then it's formed this far horizontal. So like, if this
Never
is your
mind.
image,
I know.
this would be your height, this would be your Q.
So what would the position of the object?
That would be P. Object is P, image is Q. Right? We're gonna have to get yourself familiar with the vocabulary symbols.
Yeah.
Honestly, once you get past that, it's not so bad. Okay, find the position of the object, which would be P. The magnification of the image, which is M.
Yeah.
And the height of the pencil, which is H. Which one do you guys want to solve for first?
H.
Okay, let's solve for P.
1 over P.
1 over -8 is equal to 1 over P plus 1 over -4.4.
Why is it negative for 4.4?
It's behind it.
Behind the mirror. I'm just going to do this. I would technically subtract it to bring it over, but those two negatives are going to make it positive. So that's why I'm doing that. Everyone following? I could take this, just go like this, and then add it over.
Oh,
Right?
what does that get?
I don't know what this over this gives you. You guys have to find that out. I just have an answer.
Hold on, let me.
What'd you get for your answer?
What's my answer?
Yeah.
10.
Yeah, I didn't get that.
Yeah, that makes sense. Make sure you do 1 divided by
I got 9.9.
You weren't divided by 2 questions.
About like
I got 9.2.
Okay, hold on. That gives us P. Magnification is negative 2 over P. Everybody got that?
2 over 10. So it's negative 5. Wait, negative 4.
10.
It's 0.44. What? Did you say negative 2 over 10?
Oh, it's you. Sorry.
Oh, sorry. You
So
did
2
say-
negatives are going to cancel out.
I got last one.
Do 1 divided by
I didn't even get it the first time.
You got to get the inverse.
I swung my binder here to the eye.
So you're going to need.
What is it? 0.4? Yeah.
There's your magnification.
Yeah. And max is and then H is just all what it
I mean, you can do it a lot of ways. You can use the magnification. Equals, I can't remember, is H prime or H or H?
Yeah, H over H.
And how H prime?
Because there was a negative distance magnification has a negative end.
Then when you solve for H, you should get your height.
It's not 5.7.
The image distance, yeah, but the equation itself has a negative end.
Meters, or centimeters.
Oh, I
The
say,
equation
What?
has
That
a
was
negative
not-
q, but the q's already negative, but they just cancel out. Look in the notepad.
Hey, Autumn.
Yeah, it was cancel out.